Hi, hello everyone. I think everyone is doing very well. And today I am here to teach you people a very important chapter in a 10th standard. Okay, we thought that it's a form of energy. Without help of that form of energy, today we can't able to communicate with the person those who are in very far, and we can't able to access some our things such as like a fan, switch, bulbs, and even cell phone. So it means what? Okay, I hope you people understood I'm talking about which energy. It's the electrical energy. So in 10th standard we have a chapter electricity. In childhood you might be heard this joke. Name the city in which we can't able to enter. It's electricity. We can't able to enter in electricity. Yes. It's a joke in childhood we people are used to crack on others. So the meaning that what do you mean by electricity? It's a it's a branch of physics. It's a branch of physics in which in which it deals with the flow of charges. Flow of charges or electrical charges also we can get, no problem. Electrical charges. In this chapter we have to understand few important points. Okay. Electric current, electric current denoted by I, and electric potential, and Ohm's law, electric potential and potential difference, potential difference, and next is very important, that is Ohm's law, and factors factors depends on depends upon resistance. In today's class we will understand up to here. Okay, we will try to cover the concept. Okay, now I will try to finish these topics in today's session. Okay, let's start one by one. What do you mean by electric current? Electric current, it's an easy definition we can tell. Current means what? A continuous candle. Continuous flow or movement, okay? So you know that current affairs, current account, okay? So current affairs means what? Daily news is coming, current affairs daily, okay? Day by day news, okay? The news are coming, and current account, okay? Means what? With the transaction they will do more because businessmen are having, they are holding the current accounts. Okay, this type we have. Similarly, what do you mean by electric current means? If air flows, it is called as air current. If water is flowing in a river means what? Water current. If air is normally air is flowing means what? It's a normal current. Okay, no, okay, air current is less. We can tell. If okay, air is flowing with a maximum speed. If the wind, okay, now like during the storms like this means what? What happens? The air speed increases. That is called as what? More air current is there. Similarly, if the river is flowing, okay, in a normal season, river flows with the normal speed, that is the water current is less. But during floods, what happens if the rainy season, what happens, the water speed increases, then we can tell that there is a lots of water current or the water current is maximum. Similarly, if charges are flowing in an electric circuit, if charges are flowing in an electric circuit, that is called as electric current. But how to define electric current? It's a rate of flow of charges. Rate of flow of charges. Okay. and it is denoted by electric current denoted by capital I. And so we have equation for this electric current. We have equation that I equals nothing but the electric current charge upon, okay, let me write, it's quite good if I write like this. Equation we have electric current denoted by I equals charge means denoted by Q upon time denoted by small t. Okay, and I equals, we will get final equation I equals Q by T, and Q is a charge and charge is measured in coulombs. The SI unit of charge is coulomb. Okay, and time is measured in seconds. You know already. The SI unit of time is seconds. And so then we are measuring an electric current in which unit? Yes, of course we are. So the SI unit of electric current, I will write in a short, electric current is ampere, denoted by capital A. This is the name of a scientist, Andrew Mary Ampere. From Andrew Mary Ampere we have taken this. Look, the SI units which are having a capital letters are taken from the persons, means taken from the scientists. So we understood the SI unit of electric current, and we have to understand there are other units are there, other units of electric current, such as milliampere and microampere. So what do you mean by milliampere? Means 1 milliampere is equals to 10 raised to the power minus 3 ampere, and 1 microampere means it's a 10 raised to the power minus 6 ampere. These are the small units of electric currents, but the SI unit is ampere. And you have to understand the electric circuit. I told that the charges are flowing in an electric circuit. How electric circuit looks like? So electric circuit nothing but it's wires are there, some electrical devices and power source. This is a switch and this is a power source, nothing but a battery, and current is flowing. The switch is off. Okay, when you are keeping this dot, it means switch is on. Current flows from positive direction to the negative. Because the current flows from positive terminal of the battery to the negative terminal of the battery. This is the conventional direction of an electric current. So the direction of electric current, current is from positive or high potential, to negative, or you can tell low potential. And you have to understand one thing. In this, the direction of the conventional direction of electric current was given by Benjamin Franklin in the year of 1750, and the electrons are discovered after after 90 years in the 18th century, 1890 something. Okay, so it was very long gap between the direction of electric current and the discovery of electrons. After the discovery of electrons, the scientists came to know that actually the charges which are moving in the electric circuit, not protons, or those are electrons. And the electrons are moving from the negative terminal to the, means from what? Electrons, direction of electron from low potential, or else you can tell negative terminal to high potential, or you can tell positive terminal. Then why we are doing change? Because it's a very long gap. That's why we are doing change. So still we are studying that the direction of electric current is from positive to negative terminal only. But the direction of electron, if anyone is asking, if you got a question that mention the direction of electric current and uh, electrons, then you have to tell both are opposite. The direction of electric current is from positive to negative terminal, or else you can tell that high potential to low potential, or next one, the direction of electron we can tell that. So these are moving from low potential to high potential, or from negative to positive. So what do you mean by high potential and low potential? These two terms we will understand in a electric potential and potential difference. So this is about electric current. So what you said that electric circuit. What do you mean by electric circuit? Electric circuit nothing but it's a continuous path for the electric charges. It is a path. Similarly, if you want to move, if you want to go for any place from your home to any places, you need a path. The vehicles should be have a proper path, like we have NH and state highways, national highways we have, because what the vehicles will move properly. That's why similarly in an electric circuit the electrons should move, means sorry, the charges should move properly. Actually electrons only will move, but don't get confused. The charges should move properly in a direction, right? So that's why we are providing the path by using electrical wires. That should be continuous path. That continuous path for the charges is called as electric circuit. And here the electric switch is there. So what is the function of electric switch? Means it connects the device and power source, and it saves the electricity. If I don't want this bulb, means if I don't want light, means I can turn off the switch. By this I can save the electricity, as well as I can save the life of the bulb as well as. So this helps, the switch is very important. Okay. And what is the function of battery? You know this. The battery provides potential difference in a circuit. What do you mean by potential difference? We will understand in the next topic. So battery actually it is a power source, and the battery is what do you mean by battery? Means a combination of two or more cells. Combination of two or more cells in a series is called as battery. Okay. Before going to the electric potential or potential difference, let me explain electric charge. Electric charge means Q. We have equation for electric charge. Q is equal to N into U, where N means number of electrons, and E means charge on each electron. Charge on each electron, which is having we have a fixed value, that is 1.6 into 10 raised to the power minus 19 coulomb, because it's a charge on each electron. Okay. So if anyone is asking, if charge is 1 coulomb, how many number of electrons are present in a 1 coulomb of charge? So you can use this formula to find how many charges are present in 1 coulomb of charge. Charges nothing but electrons. How many number of electrons are present in a 1 coulomb of charge? So if you want N, so you can change the equation. So N is equal to Q by E. If you substitute the Q and the E value, you know Q is a 1 coulomb. And E value, which is fixed, it is 1.6 into 10 raised to power minus 19 coulomb. Coulomb will get cancelled. And the minus powers, if they are in a denominator, if you take this denominator minus power values to the numerator, it becomes positive. For example, 1 power 1 by a is there, means if its power is 1 by a power minus 1 means if you take to the numerator it becomes a. So this and this both are equal. Similarly, so I can able to write 10 raised to the power 19. So if you divide 1.1 by 1.6 means you will get approximately 0.625. 0.625. But you want in a, not in decimal value means you have to take, if you reduce one power means you will get 6.25 into 10 raised to power 18 electrons. So it means what? 1 coulomb of charge contains 6.25 into 10 raised to power 18 electrons. These many, okay, it's a huge number of electrons are present in only 1 coulomb of charge. Okay, so next we have to understand the electric potential. Next we have to understand about electric potential and potential difference. Potential difference. Electric potential and potential difference. Okay. Electric potential nothing but it's an amount of work required to bring a unit positive charge sorry, I should not write positive symbol, unit positive charge from infinity or reference point, we can tell from reference point to other point, reference point to any other point. It means what? It should be okay, a reference point in a electric field, For example, the electric field, okay, it's very too long. Okay, for example, you just imagine, okay, it's very far. Okay, beyond the sun there is an electric field. Okay, from there to here, electric field is there. If you want to bring that charge from there to somewhere, okay, or else if you are moving the charge from, okay, just imagine. Here I am here I am is there. Okay, you can take just, okay, I am here, okay, and somewhere in the universe there is a charge. I should apply force on that charge to bring the charge from infinity to somewhere. Whether it is just if I move little bit also enough. It's what? Electric potential. Potential is nothing but means what? It's a potential. How much potential you have, how much potential that have. To bring a charge from means it's an amount of work. Work means what? We should displace the object. Similarly, we are displacing the even positive charge from its infinity point to the somewhere. The amount of work means amount of work required to bring a unit positive charge from reference point to, means from infinity to somewhere. That is called as electric potential. And here the work done is maximum. Okay, na? Because or we can tell, because if you bring very close, okay, na, from infinity to here means work is more. If you just move, okay, na, here to here means this work less, because the distance is less. That's why. Now next, the difference. What do you mean by potential difference? Nothing but that. Amount of work required to bring a unit positive charge from one point to another point, from one point to sorry, from one point to another point. Okay, in an electric field is called as potential difference in an electric field. What do you mean this? Okay, actually batteries are having potential difference. Okay. So to understand these two, actually what? Positive and negative charges, they are both in contact. In universe, they are in a somewhere. If you separate these two charges, if you separate these two charges from infinity, okay, it was, okay, it is, okay, if you are taking this one, okay, so it is somewhere, it is infinity. If you bring this object or this charge, okay, from here to here you brought it, okay, before it was here, this is A position, you brought to B place. So you are separating. When you are separating, the potential energy stored in this positive charge, that potential energy stored in this charge is only we call as electric potential. Similarly, in batteries, what happened? We have positive terminal and negative terminal. But the positive and negative terminal they form after later, but before the positive and the negative charges inside. Oscar.